Hello and welcome everyone. In this video, we are going to solve this question, and this question is basically asked by one of my students. So I will try my best to give you the best answer in a best possible way. So without further delaying, let me start the discussion of this question. As you can see, the question is, if the equation, this is the equation which is equals to k, has exactly one solution, then the number of integral value of k is what? Okay, this is the question. You can call it a you can consider this question as a JEE question, or maybe a basic kind of question from the chapter of function, or from the modulus. Okay, so it's a basically basic question, a fundamental question related to the equation. Okay, that's all. It's not quadratic at all. Okay, because it is not your quadratic function. This is not your quadratic function. Okay, so what I will do, I will try to give you the solution in a best possible way, and the best possible way should be the easiest way. So let me start from a very simple question, that is, let's assume we have an equation sin x equals to, let's assume 1, and somebody will ask you solve it and tell me the value of x. So what your answer will be? X equals to quickly 90. This is one solution. Let me tell you, this is one solution. If you have the idea of trigonometry, there is a called term general solution from the trigonometric equations. So pi by 2 is one solution. Another solutions are also there. Let me make it clear from the graph point of view. Let's assume this is our sine graph, and I'm sure you know that this is sine graph already. This is your pi. This is angle is 2 pi. This is 3 pi. It is 4 pi. This angle is 0. Okay. From the graphical point of view, what is the meaning of solving the equation is very simple. What you have to do, you just consider, let's assume y is equals to this one. So what you have to do right now, you just write down two equations. Y equals to 1 is sin x, and the another one is y equals to 1. And you just solve these two equations. That's the meaning of solving this one single equation. And this is one of the trick which we are going to use in this question. Otherwise, it will be very difficult to solve. Okay. So solution of this question will be easier from the point of view of graph. And you might be thinking, sir, how to draw this kind of graph, the graph of this function, graph of this function? It's a very complicated now. It's not complicated at all. The same kind of question is present in NCERT continuity chapter. Most probably, if I am not wrong, it is question number 34, exercise 5.1. Let me write it down. Exercise 5.1, question number 34, I think, if I am not wrong. But the question was different. The function is given similar. Similar function was given there. I think the function was mod x minus mod x plus 1. I think this was the function. So what kind of question it is? If you will ask me, modulus inside linear, it is again modulus inside linear. This is your linear. Okay, x plus 1 is your linear term. 2 minus x is your linear term. So inside the modular linear term, or maybe addition or subtraction, whatever it is, does not matter that much. So what we will do, I will not just give you the solution of this question. I will try to add continuity, differentiability with the same function. So a lot of things will be covered in one video. Now coming to this discussion. If sin x equals to 1 will be given, then what you have to do, you have to assume that y equals to this sin x and equals to 1. From there, what I have done, y equals to sin x and then y equals to 1. So right now, how many equations we have? One equation was given. Right now we have two equations, y equals to sin x and y equals to 1. Y equals to sin x is this equation, this graph. Y equals to sin x is this graph. And what about y equals to 1? I'm sure you already know y equals to 1 is nothing but this line. And what is the meaning of solution? The meaning of solution is nothing but intersection points. So these are the intersection points. And if you will see, you know that this is nothing but your 90 degree. This is your nothing but 2 pi plus 90 degree, 360 plus 90, which is 450 degree. Okay. So this is how many solutions you will get, infinitely many solutions you will get. So what is the idea here? The idea is whenever one equation will be given, let me erase all this part. Just wait a minute, everyone. So what's the idea? You need to understand, or you need to take away. What's the trick that you need to take away? Whenever this kind of question or many another kind of question is coming, okay, if you are thinking that normally it is very difficult to solve, so I think the best possible answer will be with the help of graph. We will come to that graph very soon, but the idea is you just assume y equals to sin x, and then it is equals to given y1, and from here you have two equations, this one and this one. Y equals to sin x is your one equation, another equation is y equals to 1. You just try and solve this two, and the number of intersection point is nothing but your solutions. So that's the whole idea. So the same thing we are going to do here. Let me erase this one because our question is different. Y equals to 2 minus x mod minus mod of x plus 1 is equals to k. So how many equations we have? One equation is y equals to k, which is the line which is parallel lines, horizontal lines. Okay, sorry, not parallel, it's a horizontal line. And the another one is y equals to mod 2 minus 1 minus x modulus x plus 1 modulus. Now what is the meaning of solution? Intersection point of this one and this one. Okay, so what I'm going to do quickly, I will show you this one with the help of practicals little bit with my favorite tool, that is called GeoGebra. What is my function? My function is modulus 2 minus x minus modulus x plus 1. So let me check whether my function is correct or wrong. 2 minus x minus x plus 1. So I think it is correct. Yeah, it is correct. Now let me draw another line which is y equals to, let's assume 1. I am drawing. Okay. So if you look at here carefully, everyone, how many intersection points are there between these two graphs? Green one and the blue one. Right now one intersection point is there, this one, and this is the solution. Okay. Now if you come back to the question, that exactly one solution, then the number of integral value of k. We want only one solution. So therefore k value equals to 1 is correct. K equals to 1 is correct. From the graph it's clear. From the graph it is clear that k equals to 1. Let me change this one. Let me change this one to k equals to 0. Still is there one intersection point? Yes, only one intersection point, this one. So again, yes, 0 is also acceptable because k equals to 0 is integer. So it is also acceptable. 1 is also acceptable. 2 will be acceptable. Yes, definitely. Let me see. K equals to y equals to k, which is equals to 2. So therefore k equals to 2 is also acceptable. Minus 1 also will be acceptable. Minus 2 also will be acceptable. So how many integer points are available? Minus 2, minus 1, 0, 1 and 2. So the answer of this question will be that k value will be equals to 2, k value will be equals to 1, 0, minus 1, minus 2. So total 5 values are possible. If you want a single solution, then the value of k will be, everyone, the value of k will be 5. Okay, I hope the idea is clear from the graph. What is the meaning of the question? Let me again repeat what I have we have done from the graph. This graph, everyone try to understand, this graph is basically a z kind of step, z, and y equals to k. K is basically a constant horizontal lines. Now after that, let me make it easy. This kind of graph we are getting, and y equals to k and k equals to 1 or 2, whatever it is, we are getting this kind of graph. So this is the intersection point, and exactly one intersection point, that means exactly one solution. So either you just scale it in the move it into upside, or you just move this line into downside, still intersection point will be 1. If you move it here, still the intersection point is 1. If you move it here, still the intersection point is 1. The thing is, they are asking integral value of k. They are not asking random any value, okay? Otherwise the answer will be infinite. I'm sure you are getting my point. Number of integral value they are asking. So they are for k value are 2, 1, 0, minus 1, minus 2. All these 5 values are possible. So if you will write here 5 values, you will get exactly one solution, and that is the solution of this question. Now the thing is, sir, how to draw this kind of curve? That is the biggest question, and that is a bigger question, I think. So I am trying to break it down, and I am sure you will be able to draw this kind of curve. And the same kind of curve is present, same kind of question is also present in NCERT, as I said already, okay? So always, I'm sure you already know that modulus has basically two parts. Mod of x is x, another is minus x. With the condition is positive. When it is positive, it is x. When it is negative, it is minus x, because minus of negative number will become positive. The same thing I'm going to do here. Let me erase this one. So right now what we have 2 minus x plus 1 equals to k. So k right now it is not required, I think, because we have understood what the meaning of this equals to k from the graphical point of view. So if you look at carefully, everyone, this one has two parts. One is normal 2 minus x, another one is minus x kind of thing, that is minus of 2 minus x. Again this one has two parts, x plus 1, and the another one is minus of x plus. So definitely along with the condition and all, okay? So what I will do, I will just break it down a little bit more so that it will be easier for you. 2 minus x mod, we have 2 minus x, and the condition is 2 minus x has to be positive. From there I can write that x is lesser than 2. And next one is minus of 2 minus x, and 2 minus x is lesser than 0. From there I can say x is greater than 2. Okay, so this is our breaking of modular of 2 minus x. Let me move ahead and do the next one. Mod of, what is the next one? Mod of x plus 1, and again it has two parts, x plus 1 minus of x plus 1. Condition I am writing directly, greater than minus 1, and it is lesser than minus 1. Now the interesting part will come into the picture. So everyone try to understand, and this one is my favorite, because in this way things are very much clear. Ultimately, what is my target? My target is 2 minus x mod minus of x plus 1 mod. This one I need to rewrite properly, where the modulus won't be present, will not be present, because of the modulus there is a lot of problems. I just need a simple straightforward kind of equations, and when I will break it, it will come as a different conditions, and it will come, in this case there will be 3 conditions and 3 part we will get according to the condition. Now how to get all these things? It's very simple. What you have to do, you just draw a number line, and after that you just write down these things. One is x equals to 2 point, another is x equals to minus 1. Okay, look at here everyone. This is x equals to minus 1 and this is your x equals to 2. This one you have to do for every same kind of question. After that, what you have to do, I am going to draw a graph of these two modulus. This one I am going to draw individually, this one I am going to draw individually, and I will draw it here, so that later on we will do the adjustment. Now greater than 2, look at here everyone, greater than 2, from here what we are getting, from this modulus, when x is greater than 2, we are getting this function, and which is nothing but x minus 2. Okay, so therefore this side it will come x minus 2. I hope you are getting my point. This side it will come x minus 2. Greater than 2, that means this side, I am talking about this side. So when x is greater than 2, definitely you need to understand everyone, x greater than minus 1, and x greater than minus 1 is nothing but this side. This side the function is x plus 1. So right now how many boundaries you are getting, that is also very important. One boundary is basically this one, and the another boundary is this one. Something is happening here, in between this one something is happening and something is happening. This is what you have to figure out, and that's the ultimate goal here. Okay, and as soon as you are able to figure out what will be here, what will be here, and what will be here, easily we will write it down and we will fill up these gaps along with the conditions. I hope you are getting my point. So x greater than 2, we are getting minus of 2 minus x. Now from the another modulus, what we are getting, we will get x plus 1. So I am going to write here everyone, when x is greater than 2, from this one, from this modulus we are getting this one, from this modulus we are getting this one, and I am going to just write down, I am going to write down here. So it will be minus 2 plus x, if I will remove the bracket, and it will be minus x minus 1. So x cancel out. Ultimately what we are getting here minus 2 minus 1, which is minus 3. So let me write it down, minus 3 here. Now let me do the same kind of analysis in this part. So x lesser than minus 1, x lesser than minus 1, that means this condition is satisfying and we are getting minus x plus 1. And x lesser than minus 1, that means this condition is satisfying and therefore we will get 2 minus x. So let me write it down everything here. 2 minus x, and minus of minus will become plus, it will be x plus 1. So x cancel out. Ultimately what we are getting here, we will get 3. I hope everyone the explanation is clear, because right now it is important to understand. So this is 3 and the condition is x is lesser than minus 1. So what is left between minus 1 to 2, what is happening? Okay, that is the interesting part, and I hope this will not be very difficult to understand. Now come everyone. So right now our aim is to find out what will happen in between these two, minus 1 and 2. So come to the condition. Condition will give you the correct results. Greater than minus 1. Everyone look at here. Greater than minus 1, what we are having? We are having x plus 1. So this is our greater than minus 1. So we will get x plus 1 from here. And greater than minus 1 but lesser than 2. Try to understand everyone. So this condition will be correct or this one condition will be correct. That we need to figure out. So what your thought will be, I just want to know. I am just giving you a little bit of time. You just think. Again, let me repeat. Greater than -1, lesser than 2. This is what I want. So I think I have given sufficient time to think about this one. Greater than -1, if you look at carefully everyone, it will come from here, which will be x plus 1. So it is x plus 1. And lesser than 2, that means this condition is satisfying and it is nothing but 2 minus x. So let me write it down. 2 minus x minus x plus 1. So if I will rewrite everything, then it will be minus x and minus x will be minus 2x, and 2 and minus 1 will be 1. So it will be 1 minus 2x. So let me erase this one. Let me erase this one. So it is 1 minus 2x. So I hope you have understood what has happened. Greater than 2, height is -3, lesser than -1, height is 3, and in between we have a straight line which is having negative slope, that is 1 minus 2x. And this is what exactly you already have seen in GeoGebra. Let me show you everyone. In GeoGebra what we got. Look at here everyone. This side onwards, this is your height is 3, -3, look at here. This side, look at here everyone, your height is 3. And in between we are having this straight line which is 1 minus 2x. This is your 1 minus 2x straight line. Okay, so the same exactly graph we are getting which is matching our function. Okay, let me add little bit more thing. So our graph is roughly looks like this one, this line, this one, and this one. So I used to call it basically a Z-shaped graph. Z, English alphabet Z. I know that it is a little bit different, but yeah, you can assume this is your Z-shaped. So what is the interesting point about this function? This is called a corner point. And this corner point is very interesting. And this corner point is something where the function is not differentiable. This you need to remember. This corner point is something where the function is not differentiable. Now you will talk about continuity. Is it continuous? Yes, it is continuous because it is your absolutely continuous function. The reason is there is no gap in the function. Everywhere the function is smooth, no gap, so it is absolutely continuous function. Another way we can say that why it is continuous, the reason is, look at here everyone, modulus is a continuous function, this is also a continuous function, addition of two continuous function or subtraction of two continuous function is always a continuous function. That is the theory of the continuity. So this is the reason we can say that in this function is it continuous everywhere? Yes, it is continuous everywhere. Is it differentiable everywhere? No, it is not differentiable everywhere. Where it is not differentiable, this point it is not differentiable, at this point it is not differentiable. So this kind of question already came this year, 2024, this kind of question came. If m is the number of discontinuous point, n is the number of non-differentiable point, then tell me the value of m plus n or something like this one. Okay. So in this question, number of discontinuous point will be 0, number of non-differentiable point will be 2. So therefore total answer will be 2. You have to mark 2. Okay. Let me little bit talk about the question which is present in NCERT. I think it is x modulus x and then modulus x plus 1, and again if you will draw in the same way, you will get, I think, the same kind of graph, this z kind of graph, and this is also called, this one is nothing but corner point and the function is not differentiable. If you don't know why it is not differentiable, you can write down in the comment. I will try and make a video on that. So I hope everyone you like this video, okay? And the way of solving is very easy. You have to assume that y equals to the given question equals to that one. Y equals to whatever will be given equals to whatever will be given. Then this two will be equation one graph and this two will be one graph, and try to find out the intersection point. That's the whole idea. So I'm stopping this video here because it is a query of one of my student asked me this question. I just thought that let's make a video on this one so that everybody will get the benefit. Thank you so much. If you like the video, kindly subscribe if you want. If you are thinking I will not subscribe, that is also okay, but I will try my best to give you the best kind of ideas with the help of GeoGebra. Thank you everyone.